I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tarr and Tom Ray. We're talking about the right way to attach audio connectors to your audio cable. Hey, it's important. That's next on TWiRT.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 95, recorded August 17th, 2011. Audio connectors. This Week in Radio Tech is brought to you by Omnia Audio and the hugely popular Omnia One processor. Get your 5-band upgrade today at OmniaAudio.com. Hello, it's time for This Week in Radio Tech. I'm Kirk Harnack along with Chris Tarr and Tom Ray on this episode. We're going to talk about radio engineering, broadcast engineering, and some of the things you got to do to just get things done around a radio or broadcast facility. But you can apply these techniques to audiovisual facilities or the audio portion of television, for example, or if you're a podcaster, if you just like home stereo stuff and really have a fantastic system, hopefully you'll get some advice from us that will help out. And maybe we can learn a few things too, because the chat room is always alive with good questions and sometimes really good answers. So I'm Kirk Harnack. I work for, there's the chat room. It's at irc.twit.tv if you want to participate in the chat room. I'm Kirk Harnack. I am, a little disclaimer here so you can know where I'm coming from. I'm employed by the folks at the Telos Alliance. That's Telos and Omnia and Axia and Linear Acoustic. I'm the director of sales and marketing for that company, and they are just a terrific employer, and also they're also a sponsor of this show. So that's my background, but I also do engineering for some radio stations. I'm part owner of several stations. I own the part that doesn't make any money, which is exactly why I work for Telos. However, we got a couple of engineers who here with us, regular co-hosts, who are rolling in dough. First of all, we'll go out to Mukwanago, because it rhymes with dough, and talk to Chris Tarr of Entercom. Hi, Chris.
You know, nobody told me I was making any money. Where'd this come from?
I just said you were rolling in it.
I'm rolling in something, that's for sure. Yeah, it's not money, though. I'm the director of engineering for Entercom's radio stations in Madison and Milwaukee. I also am co-founder of the site broadcastengineering.info, and you can find out all about me at geekjedi.com.
Very cool. And Chris, I take it you've done a little wiring and put a few connectors on at the end of a piece of cable, haven't you?
Oh yeah, I've done my share of studio wiring for sure.
Yeah. We're going to talk about that, and we're also going to talk about RF wiring. So let's bring in our other co-host, Tom Ray, from the Hudson Valley of New York. Hey, Tom.
Who's got a great amplifier. It's 50,000 watts, and it goes to 11.
You do. You have a heck of an amplifier out there in the New Jersey Meadowlands. Tell us about yourself, Tom.
Well, I'm VP of Engineering for Buckley Broadcasting and work out of WOR Radio in New York City, AM 710, with the 50,000 watt blowtorch. And anyway, I'm just here to have a good time because you told me there'd be beer. So, hey, you know.
Well, did I mention it's BYOB?
Oh, man. You didn't mention, you forgot that in your memo.
Actually, I got a refrigerator here in the office full of beer. If you want to come on over, you're welcome.
Well, you know, just push one through the camera. I'll reach out and grab it.
Wouldn't that be something? Hey, so on this episode of This Week in Radio Tech, we're going to hit one little topical item first, just to get a couple thoughts on it. You know, engineers certainly have opinions on everything in a broadcast station. You know, some engineers, a lot of engineers, maybe mostly all engineers, think that, you know, they should put me in charge of programming because I could really make this place walk and talk. Or, you know, they should put me in charge of sales because, you know, these people, I tell them what they ought to sell as far as remotes and such and whatever. And sometimes engineers at a radio station far outlive the other positions at the station, right? I know of engineers who have been through 2, 3, 4, 5, 6 general managers. They've been through several sales managers. They've been through air staff over and over and over again, and the engineer is still there. Now, does that mean that engineer is not upwardly mobile? I don't know. Maybe it does. But here's the subject at hand. in the U.S., we are finding that a lot of, or several, in anyway, in big markets, several traditional news talk AM radio stations and maybe some sports talk AM stations have moved or are now simulcasting with an FM station. This has happened in Atlanta. This has, I believe, has happened in New York. And there are other cities as well. I'm sorry, I try to keep up with engineering, not with programming, but I think this is pretty interesting that some broadcasting groups are finding that, this old album rock format or this old whatever mix format is not working for us so well anymore. And our AM big news talker, in Orlando, WDBO has just started doing this. Our big news talker is popular enough that we're going to put it on that FM slot and see if we can maintain or get a bigger audience that way. Is this signaling the demise of AM, the AM band? Tom,
No,
what do you think about this?
No, I don't think so. I think a lot of the stations doing that may actually be looking for a slightly different audience because, in many circles, the AM band is considered grandpa's radio. And, those of us who work in it know it's still a very viable medium. And WR has listeners from one spectrum of the age group to the other. But I think by moving that format over to an FM, you're going to probably going to pick up a slightly younger crowd, and you might pick up somebody, for example, if you have a cell phone with a radio in it, let's go there. You don't have the AM band on it. You've got the FM, so they could potentially pick up a different audience.
Chris Starr, you started to jump in there after I asked the question. What do you think about this? A demise of AM, smart move by programmers, losing revenue from their former, whatever it was, classic rock station or mix station or, Hungarian yak station. What do you think about that?
The bigger thing that they're not talking about here is this 100% revolves around Arbitron's PPM. That's what triggered all of this. That's what's continuing to make this happen. It really isn't making or losing money on the previous FM formats. It's that in these markets where the FMs are moving over, or these news talk AMs are moving to FM, they're getting rewarded in the PPM numbers. It seems to favor some of those formats that may have been considered older skewing. Things like oldies are doing very well. And I think, too, one of the things that we're finding out is that as these AM news talk stations have figured out before, there's a lot of money to be made. And sometimes, especially if you're the big AM that has many different sports teams on there, you've been giving away overflow games to competitors in the market. Well, here's an opportunity to kind of keep it in the family. So are we going to see more of these? I think we're going to see a lot more. I think we're going to see a lot more of FMs picking up, or AMs rather, picking up FM translators in markets where it makes sense. They just did that with Minneapolis, putting their sports station on an FM translator. So you're going to see a lot more of that. And it really kind of boils down to PPM and Randy Michaels, for all his warts, has really got it right. His music moves on to things like Pandora. Again, here's another opportunity where radio can grow with it, which is putting talk formats, spoken word formats on FM.
Gotcha. All right. So, but the first thing you said about this was PPM being driven by PPM. Help me understand why that is. Do talk formats do really well with PPM?
Well, the talk formats have huge amounts of TSL, time spent listening, more so than, they may not be as high of QM. Sometimes they are, depending on the person that's on the air. And what we're finding, or at least what I'm seeing, is that, these stations that are taking their big AMs and simulcasting them on FM, either, maybe have an AM station that isn't reaching an entire metro. Maybe they're trying to bring in a whole new, whole younger age group to their radio station. So I think what you're finding is that, there's a whole new area there to discover, and PPM has been very good to news talk stations. Again, a big component in ratings is time spent listening, and talk formats still rule when it comes to that.
Let's say that you're a class legendary AM station like WOR or like WDBO in Orlando or any of these other AMs that have now become or simulcasting on an FM or are thinking about it. From an engineering perspective, what what do you need to do to help transition that FM station from, let's say, a music format that it might have been before to that news talk format? Engineering-wise, what needs to happen to optimize and to make the best use of the FM facility for a talk format, whether it's sports or news? Tom?
My thinking is it's primarily you're going to want to get into the audio processing on it, because what works for music and you can bang your head against the wall and just nail the audio to the wall with a processor, like a lot of program directors want to do. Doesn't necessarily work on FM with the talk format, because you're going to really hear that distortion and that clipping in the audio. You also want to lighten it up just a little bit, make it breathe a little bit, because people don't, as opposed to the music, they don't talk in your face all the time. They talk with different inflections. They speak a little softer. They speak a little louder. So you want to lighten it up a little bit, make it sound a little bit better, make it sound a little more natural. And then let's get into the studio. I mean, if all you're doing is simulcasting the AM, you don't have a problem. If you're taking and putting a talk format on a music FM, you may have to reconfigure the studios for a talk format. I mean, a studio that's set up for music may not work very well for talk, especially if you're interviewing guests, because on a top 40 station, the guest is off to the side. You can sit there and talk to him, and they go out the door. But on a talk station, you may be talking to that same guest for the whole hour. You want them in front of you. You want them to be comfortable. You want to have eye contact. So there are numerous things to think of, and how you're going about this, and why you're going about it.
But on the actual transmission system, the transmitter and antenna and all that kind of stuff, there wouldn't be any differences there. You're talking about audio processing and then studio conveniences, assuming that, let's say, the originating AM and this new FM that's simulcasting, assuming they may split off from time to time, because Chris Tarr mentioned that, hey, maybe they've got another sports team to play on that. Chris, what do you think about, if you're an engineer and you say, you know what, we're going to blow up the mix format that's on our FM station and put our AM news talker on there? What's on your to-do list to make that happen?
Oh, there's a lot of things, because one of the things you got to worry about is you have some of the things that are inherent to FM that really aren't real noticeable in a music format, but are going to be very noticeable on a talk format. Things like multipath, picket fencing, things like that. And Tom mentioned audio processing. In a way, you almost you're coming from an AM format where you do a lot of heavy processing and a lot of heavy clipping, and there is a lot of presence to those microphones, and it almost sounds unnatural when you flip it over to the FM, and everything sounds like NPR, very quiet. And not only that, but you need to have some average volume there to kind of overcome things like multipath issues, picket fencing, road noise, those sorts of things that come up in a spoken word format. So you do have to kind of look at, your transmission system. You do obviously want to look at things like audio processing, studio transmitter lengths. Again, you're going to have issues potentially with cascading codecs if you're talking about people that are going out in the field with digital recorders, where you're recording something in a reduced bit rate and it goes into your automation system at a reduced bit rate, through your STL at a reduced bit rate. There are issues like that as well. So there's a little more to it if you're adding this FM component that you had with your AM component, which with AM especially hides a lot of things that you normally wouldn't hear. So, all of a sudden now it's all very clear on an FM format or on an FM signal. So you really have to be sensitive to that. But, one of the things that came up when we discussed it, possibility of doing these sorts of things, first thing that comes into my mind is, how do you overcome multipath? You used to be able to just crank your audio up and turn down your separation a little bit, and you could kind of overcome that noise. In a spoken word format, it's not so easy.
I think one of the interesting things about audio that you've always heard all your life on an AM station, and then you hear it either maybe direct from satellite or now you hear it on an FM station, is the change that you hear in someone's voice. Let's say a longtime newscaster from ABC Radio News, for example. For example, one radio newscaster on ABC, Tom Hart. Heard him for years on AM. and then I heard him on an FM station. I thought, that's Tom Hart? Same thing happened with yeah, go ahead.
I mean, here's a true story. Our FM, our AM sports talk station, I put on an HD2 channel. And at first I gave it its own processing. And people thought it was a little weird. And I finally just took the feed out of the AM processor and sounded great. People loved it. So I was like, okay, we'll just run it out of the AM processor right into the HD2. But people actually preferred that sound because it sounded more like what they were used to. And I'll tell you, it did. I mean, obviously with road noise and the enhanced dynamic range and things, it really kind of made you think about, do you really want to, how much do you want to back off that processing when you're running a talk format? And another thing I'll bring up real quickly is, some people are doing, and there's pros and cons to that, is some people doing a talk format or turning off the stereo pilot. That helps things like picket fencing and coverage and things like that if you're not doing any stereo programming. However, there's that psychological thing about hitting scan and seeing the stereo light come on. So, there's also two schools of thought on that as well.
Yeah. Okay.
And Kirk, you mentioned hearing that newscaster before. For those of us old enough to remember, that's kind of like listening to a Beatles song on CD. If you remember hearing it originally on an AM station, it sounds good, it sounds great, it's in stereo, but it's not the same.
Yeah, you're right. Well, let's get to the subject of wiring and connectors. We're going to make the next 45 minutes or so educational in nature. We're going to talk about not that me or Tom or Chris knows the exact best way to do this or always the best practice, but I think each of us have built enough studios to where we have an idea for ourselves what works well and what doesn't work so well. We're going to kind of divide this into two subjects, audio connectors, and I'm going to add to that and include IT connectors, which is pretty much the RJ45, right? And then you have the subject of RF connectors. So let's hit on the audio connectors first, but the RF, if we don't get to them on this show, we'll do them on a subsequent show because they're pretty darn important to get those right. But I think more people, whether you're a podcaster or a broadcast engineer, you're going to deal with some audio connectors. And I'll go ahead and kind of kick things off with talking about my favorite connector to hate, and that is the famous RCA connector. You know what this is? I should have had one right here at the desk, and I guess I don't have one here handy, thank goodness. The RCA connector, the one that's got the pin in the middle and that's surrounded usually by 4 little tabs, that's so they can, flare out just a little bit and make a friction connection against the female RCA connector, usually on the piece of equipment. And we all know RCA equipment, RCA connectors, because they're on the back of, every stereo system out there. There you go. Oh gosh, you can buy them at Home Depot. Well, they're gold-plated. How lovely. That's important, They sound better that way, and make sure it's oxygen-free gold. So, yeah. So usually, in fact, I hated putting these connectors on to cable. I hated it so much that whenever I could, I would buy a commercially made and molded cable that had RCA connectors on them. I'd cut the cable somewhere, some number of inches, some feet or a foot or two away from the connectors, and then I would splice my broadcast style wiring. Now, when I say broadcast style wiring, well, in broadcast facilities, typically we're dealing with balanced audio ins and outs from analog gear. And if you're using AES EBU in the AES3 format, then typically we have a balanced connection there too. Balanced meaning that neither side is ground. So typically we have some wire, like a balanced audio cable. We have a red wire and a black wire, and neither one of them is ground. There's often a shield around those and a drain wire that carries that shield to ground if you wanted to. So RCA connectors are not balanced. You could design a system such that it was, but then there'd be no shield whatsoever. So RCA connectors are typically unbalanced, but sometimes it's okay. If you know what you're doing, it's okay to connect a balanced connection to an unbalanced input, let's say, or even an unbalanced output to a balanced input, if the electronics design is such that it's going to accept that and maybe the distance isn't too long and the grounds are all pretty similar. It's better to use a balancing device, like a Henry Matchbox or something similar to that. But my point about the RCA connectors, let me get back to that. You can buy an RCA connector that you can solder the wires onto, right? So you unscrew the RCA connector and you pull the back of it back, and you got to try to remember to slip the back of the connector in the right orientation over the wire first. I can't tell you how many times I put an XLR connector on and then realized, oh, I forgot the back again. So we got to start all over again. And
if it's your first time soldering an RCA connector, make sure you have more than one.
Yes, yes. Okay, so my technique with an RCA, let's say I'm going to take I'm going to take some Belden, I guess 9451 wire, or the equivalent, twisted pair, balanced twisted pair, wire, and I'm going to wire it onto this RCA connector. So I'm going to take the back off and slip that over the correct orientation over the Belden wire. Then I'm going to take my wire strippers and pick the right setting to strip off just the outer jacket, and maybe it'll grab the shield, the foil shield, and maybe it won't. But I'll strip off, probably. Actually, I'll strip off a lot more than I need, maybe a couple of inches worth here, just so I can easily play with the wires. And typically, when I was wiring an RCA, I was making this an unbalanced connection. So I would pull the drain wire to the side. I'd make sure the foil was all gone. Then I would strip the black wire all the way as far down as the drain wire was, all the way down to the back to where this jacket was. And then I would twist the drain and what was the black wire, now stripped, together. Okay? So now the black wire and the drain wire, or the shield, are the same thing. All right? Then I would kind of hold all. Now all I've got is a red wire that's not stripped, and it's about 2 inches long. So I would hold all that up to the RCA connector and see where, okay, I'm going to fit the red wire in through the middle and see how much of it comes out, and see how much of this do I need to strip. So I'd strip off, typically it was about an inch and a half. I'd strip off the of the red wire, twist that nice and tight, insert that up the middle of the RCA connector, so now the stranded part is coming out the hole at the end of the tip of the RCA connector, and there we go. Then we're getting ready. Then there was always this little tab that you could, with needle nose pliers, you could wrap these little tabs around the rest of the wire. So I'd wrap that around the back. Typically, I'd wrap it around the jacket itself to hold that in place and give it a little bit of strain relief. Now I take my soldering iron, and I'm going to go heat up and apply some solder to the stranded wire coming out the tip. And so I'm going to get a nice connection there between the stranded wire and the tip. And I may even overload it with solder or let it suck into the tip a little bit. And when that's cool, I'm going to take my diagonal cutters and cut that off. So now I've got just a soldered connection with a little bit of a diagonal point there at the end. Now I'm going to take the black wire and the drain wire that I twisted together earlier, and I'm going to kind of wrap them or touch them up against the side of this tab that's holding the rest of the wire. And I'm going to solder that. I'm going to lay a nice little bit of solder in there, and I'll cut off all the excess wire. Now, when that's cool, of course the danger is there, don't heat up the tab too much, because then it's going to wear into and bite into the jacket too much. Check the security of that. Take the back of the RCA and put it all back together and wrap it up. Now, I never had any better way to do strain relief on that. But if it was going to be used in a mobile situation, then oftentimes, after a few months or a few years, this would end up becoming a strain relief problem. It would end up breaking there at some point. The important thing there was to heat up that center enough to make sure it had a great connection, and to heat up the twisted wires enough, the black and the drain wire, and make them have a real solid connection. Get your soldering technique down so you can solder these things on well. So there's a good mechanical connection there as well as a good electrical connection. So that's how I would typically do RCA connectors. Boy, that was a lot to go into. But if you do it right, and it's got good mechanics to it as well as the solid electrical connection, then it can run for if it's not in a mobile situation, it could just sit there for the next 20 years and work just fine. All right, that's enough of that one. Hey, Mr. Tar, what connector do you want to tackle for us?
Well, one that I was actually working on a few weeks ago, and I may have mentioned this before on the show. I don't remember, but it's a true story. We're going to go with your typical DB15 connector, which is a 15-pin sort of looks sort of like a serial connector on the back of a computer, and you'll find these a lot in automation systems. You'll find these a lot in studio switchers for serial data. So we were putting this network on the air, and I needed to take a relay closure and feed it into our switching system. So I got it all wired up the way it looks like that. So on the back side, you can see on this picture that we have on the screen here, this is the front side of the connector. On the back side are these tiny little cups that you set the wire in, and then you get a little solder in the cups, and that holds the wire in. So on the inside too, the backside has little numbers that label the pin numbers, so you know where you're going. So I wired up this remote start button to this connector, plugged it in, nothing. It was not working at all. I'm pressing the button, I'm grabbing my multimeter and testing, and you hit the button and there's continuity and it closes it. I can't figure it out for the life of me, and I'm just tearing in it. Well, it turns out that I didn't put the wires in the right pins because I didn't have glasses on.
Hey, you guys got to cut to me for a second. While you were talking, Mr. Tar, and while you were on screen, I was getting my reading glasses out.
So here's
golly, these are tiny little numbers.
So what I did is that, I had reading glasses and I never wore them because I hate looking over the top. And so I went to my optometrist. They said, okay, I'd like some bifocals, just clear on top and the magnification on the bottom, so I can do this wiring. And they did an eye test. They said, well, the good news is I can get you bifocals. The bad news is the top part isn't just going to be clear.
Yeah.
So I ended up getting, especially with computers, I got the progressive lenses. But that's actually it's a very hard thing to do, and you get that actually with any number of connectors. Connectors are small.
Would you guys go back to that picture of that DB connector that showed both sides of? There you go. Oh, there you go. All right. I got to ask both of you guys. Let's start with Chris Tarr, and then we're going to go to Tom Ray. What is your technique for actually soldering a wire properly into one of those tiny little cups, getting a good connection, making sure that it's mechanically secured by properly flowed solder, and you don't get a solder bridge or a strand of wire over to the next cup? How do you do
it? It's very easy. It's very easy. You get a real nice fine-tipped soldering iron. And you prep the wire, get some solder, just tin the ends of the wire that you're going to put into the cup.
How much are you stripping off before you tin it?
Just a very small amount. I would say, it's just I kind of do it by feel. I couldn't tell you exactly how much, but just a very tiny amount that would just fit inside the cup.
1/8 of 3/16.
Yeah, about 1/8 of an inch. Yeah. And tin that up so there's some solder on there. Then you go to the cup and get a little solder flowing inside of the cup so that just the inside of it is filled with solder. Then you take your wire and your soldering iron and you heat up the solder in the cup so it starts to flow, and you get the wire in there and let it go. And as soon as the solder dries up, you've got a really good connection in there between the piece of wire and the solder that's in the cup. Now, one thing you really want to do to prevent bridge connections or even to help get the wire in is another little trick that I do is I tin it up and then snip the end. So I actually tin up a little bit more than I need and then clip the end of the wire because with the tinning it makes the wire nice and hard, and so you get a really nice edge on it when you clip it, so you don't have any frayed wires sticking out or anything like that. So when you try to slip it into the cup that's soldered, you don't have wires spreading out.
Look at that. Thank you guys for finding that picture. Excellent.
There's a good example of where it went wrong. If you look at that orange wire, you can see where that wire is frayed out. That's going to be a potentially bridge connection there, right there. So, what I would have done there is, obviously done it over, but make sure you've got that wire is nice and tinned, and then snip off the end so you have a nice clean end to it, and then literally just warming up the solder that's in that cup, and then you slide the wire in, and you're done.
Because when you're trying to apply this, and I've done it very similar to how you describe, except I got to point out when you said pull it back until the solder dries or cools, you've still got to use your finger or a tool or something to maintain a little pressure on the wire in the cup so that stays there and stays still. At the moment the solder hardens, it's got to be still. Otherwise, you get some crystalline action there and a poor connection.
Well, so and that's why it's real important too, by the way, to make sure that you're not using your. A lot of people take their soldering iron and crank it to 11, and you don't want to do that. And that's why, because you want just enough heat for the solder to flow, and if you do that, that wire is not going to be so hot that you can't hold it in there till the solder cools off.
So can you make sure that you're using different solder formulations melt at different temperatures? I would think you'd want to do a little research and use a solder that melts at a lower temperature, and then have a soldering iron that's just the right amount, because you don't have a lot of metal to heat up here. You're not trying to to do something really big here. This is a very small piece of metal, that cup, and the end of the wire you're trying to heat up at the same time. You just want to melt it enough to get it in there, solder flows, and then back off and let it cool, and you can make this connector.
And just use the very tip of the soldering iron to do the work. Don't take the whole side of the tip or anything like that. Just take the tip right in, and it's literally, it'll take less than about 15 seconds for things to happen, and then you get the wire in and you back the iron off, and it cools pretty quickly.
I got to tell you, doing this wrong can result in a lot of frustration, and I'll tell you what I did wrong on this. Years ago, I was engineering for a station. We had a remote studio morning show, and connecting these two facilities, we had the classic Zephyr from Telos with an ISDN line at each end. So, and we were also using the contact closures and tallies from the other direction. So in other words, the morning show done at this remote studio, they had tally lights for when the automation was, when it was time to go to them, or a spot was over, or whatever they were for. And then they could push a button at the remote studio and start the next thing in the automation, or force a return back to the studio, or play the top of the hour ID from the automation system, because the spots were all in the other city. Well, this worked most of the time, but some days it didn't work. They'd push the button and nothing would happen. And it got to be very frustrating. In fact, I ended up having an argument with the station, with my business partner, about this. And it turned out to be my fault. I had hastily soldered the ground, or the common connection, from these buttons into the little solder cup on this. In fact, in that case, it was a 25-pin connector. And you could take it apart and look at it. It was all there. But if you took a little tool and touched the ground wire to the common pin that I was using for the common pin, and touched it just hard enough, popped right off. And that means that what you really had there was I don't know if it's a crystalline connection, or if it was just the rosin, the solder's built-in rosin that was kind of gluing it together, but it wasn't a solid electrical connection. So all I did was heat it back. Didn't even have to apply any more solder. I heated it up, reflowed, make sure it was all good temperature. It flowed. Never a problem again.
And that's why you always want to, when you're doing connectors like that, before you put them back together, just give each wire just a little tug, make sure it's in there good. And somebody else mentioned in the chat room, a great idea too is make sure you've got a pan vise if you're doing this a lot. It's great to be able to hold the connector in while you're working on it, so you can have two hands to hold. You don't have to try to, with one hand, hold the wire and the connector and the soldering iron, and some sort of vise or something to hold it down. In fact, in a pinch, I've used things like forceps, stuff like that, to just keep it steady while you're soldering.
That's fancy. I always hold the solder with my mouth. Is that safe?
Yeah, I'm thinking that probably not a good idea.
Yeah, I think OSHA
may want to have a word with you about that.
you got the wire, you got your soldering iron, and I need to hold the solder. So you pick it up with your mouth, and no, bad idea. Then you got all this smoke going up your nose when you're that close to it. Yeah. All right. Hey, Tom Ray, you've wired a couple things in your life.
Just a couple.
Yeah, you want to comment on this kind of connector, or you want to move on to your own favorite connector?
No, everything Chris said was fine. But what I've taken to doing more recently, just because I'm not necessarily getting lazy, but it's just a lot easier. If you're not in an environment where it's going to be you're going to get corrosion. Our transmitter site is where our satellite receivers are, and you find a lot of these connectors on satellite receivers. It's pretty much environmentally controlled in there. It's never too humid. It's never too dry. So I generally don't worry about corrosion. So what I've been doing is I've been using the crimp-on connectors, and I use these little pins. And if you're going to use those, it's a good idea. I usually just very lightly tin the wire. So, much to what Chris said before, so it doesn't kind of fray out and splay out, and then it'll crimp very nicely in here. But it's also good, instead of using the cheap $15 crimping tool, get a real one, a ratchet tool that's going to get in and give it a good hard crimp and get that crimp down there really, really good and make a really nice tight connection. give it a little tug, make sure it's okay, make sure you didn't break the pin off, and then instead of using my bifocals here, Chris, I have a lighted magnifying lens that I use to look at this and read the actual numbers on the thing before I slip it in, because once these things go in, you ain't getting them out again. So that's the only bad thing about these crimp connectors.
I've used those before with excellent luck. I haven't, however, used with excellent luck the crimp-on XLR connectors. I don't know if you've seen those before.
No, a crimp. Now, I've seen the solderless, kind of lay the wire in.
Solderless. Yeah.
Okay, it's the solderless XLR. You haven't had good luck with those?
No, I've had horrible luck with those, actually. I bought a bunch of those for a project I was doing with an automation system. I ended up going back and just soldering the wires onto the no solder connections to make sure they stayed. And I may have been operator error in putting these things together, but I think probably 1 out of every 3 connectors just never had a really solid connection.
Are those the ones, Chris, where you take the wire and actually loop it around the little thing, and then when you put the thing together, it actually does the insulation displacement?
Yeah. As soon as you tighten it up, it ratchets down and essentially nails the wire onto these pads, I guess is the easiest way to describe that.
Yeah, I can't imagine that would be really great in a wet or a location where you can actually get corrosion on the thing, because oof.
Tom, you just mentioned a kind of a key phrase there that we should have mentioned, and that is connectors that don't require soldering are typically based on ID, or insulation displacement, where the design of the fork or the whatever that the wire is going into will pierce the insulation on the wire and will touch the copper, or the tin copper inside the wire itself. There you go. There's an example.
Yep, those are the ones I was working with.
And here's an example. The most common one people would probably recognize is the one on the end of their phone wire.
Aha. You mean an RJ connector?
An RJ45. It's the same principle. You stick the wires in there with the insulation on, you crimp down, and the crimper takes the little pins, pushes it through the insulation on the wire, and there's your connection.
Yep.
Well, here's a perfect example of that where it can go wrong. And this is actually, I was talking to Kirk on the phone about this earlier today when we were talking on the phone about this. I did the studio build out in my Madison facility. And typically when you're building these out with these big 66 phone company punch blocks, you've all seen them. It's the white blocks with the V connectors inside the V blades, and you punch down the wire into the blade with a punch tool. Typically, when you wire these things, you get these blue hose from Gepco, which is it's like this big blue hose with a bunch of multi-pair cable inside of it, and you fan them out and you punch them down to this punch block.
Yeah.
Well, the stuff that they sent me wasn't actually the stuff that was meant for that, and I didn't realize it till after we had put it all together. They had actually sent out the heavier duty model, and so unbeknownst to us, we punched all these punch blocks down. Most of them didn't work because the shielding, the insulation was stronger than what the blades were used to cutting through. So they actually had this like almost Teflon coating on the wiring. So you'd punch them down and they'd seem to get right on the punch block just fine, and the punch tool would cut off the end and they'd be in there nice and tight. And we went in to apply audio, and every studio had something that was left channel only or right channel only or something like that, or didn't work at all. And it turns out that a good 60% of the punches didn't work at all because the insulation was too hard, and so the blades on the 66 block, and there you see them lined up on the wall there, didn't cut through the insulation. So there's a situation there too where you can get bit by that.
Now, let's talk for a minute about, and hey, we may not know all the right answers, but our own experience can tell us some truth. There are some insulation displacement connectors that are intended for solid wire cabling, and other ID connectors that are okay to use with stranded wire. And in broadcast, we've always tended to use a lot of stranded wire cabling for audio because we thought there'd always be a little bit of motion or moving here and there, or moving some equipment around, and that's just it got to be standard what most of us tended to use, stranded, twisted pair, shielded wire. And you brought up 66 punch blocks. They just showed that on the screen just a moment ago. I was always given to understand that 66 blocks were intended for solid wire, not stranded wire. And so the very fine mechanics, the tolerances, the exact shape of the fork that you would punch the wire into was meant for solid. I always had these work just fine for stranded as long as I didn't, double or triple them up like some people do. Some people would use, a single punch down on a 66 block as a point where you could connect 2 wires or 3 wires. I never had very good luck with that, so I never did that. I always, would use the adjacent fork or the next fork over from that to punch in extra wires if I needed them. But I always used, as far as I remember, I always used stranded wire in all my studio wiring jobs. Now, we have non-stranded or solid wire, of course, in the form of Cat 5e or Cat 6 cable that's become very common in of course, LAN wiring, but also in AES-EBU wiring. You can use that cable. It's close enough impedance. And a lot of now balanced audio wiring is done on that kind of cable. Tom, you've got a facility there where you've got a lot of Cat 5e or Cat 6 cable running around. Tell us about connectorizing that stuff in the field.
Well, once you get used to it, it's okay. But Cat 6 has a tighter twist. The wires are twisted together in a Cat 5 or Cat 6 cable, and the number of twists per inch and how tight they are and how close everything is together determines whether it's a Cat 5 or a Cat 6 cable. Will determine the upper frequency that cable can carry, and also will somewhat determines the noise floor. Learned that from Steve Lampin from Belden a number of years ago. But the Cat 6 cable, because it is so tightly wound, can be a real pain to put into the connectors, because you have to untwist it, you have to get it, and some of the RJ45 connectors for Cat 6 are exact. If you're dealing with gigabyte connections, you have to make sure that the color code is correct. You also have to make sure that the wires are placed properly. And I don't have an RJ45 here. Matter of fact, I can't find my RJ11 right now. You have to make sure they're placed exactly center of where they have to go in that connector. And some of these connectors have these little, it's a
like
little
a comb?
piece of plastic with holes in it, and you have to put the cables in there, and that slows you down. But let me tell you, we tried to speed things up a little bit, and we cheaped out with a couple of cheap connectors, and those are the connections that failed and wouldn't run at the gigabyte speed. So, it once again, you kind of get what you pay for, and you get out of it what you put into it. But once those things are in, once they're on, it's hard to break it. I mean, we tried. It's hard to break them off. It's hard to get them to move around. It's hard to get the speed to shift, and everything works like a champ. But what's important when you're putting audio over these things, it's important to make sure you have you're using the same pair, and you're using the pairs in the order that they're intended to be used in, to keep the noise floor.
Yeah, it's important
and crosstalk into pairs where they are.
It's important not to split a pair. So
exactly. Well, that too. Yeah.
Yeah, your balanced wire is indeed a pair that's twisted together itself. Chris Starr, you had a comment about 66 blocks. I mentioned that I had used them a lot in building radio stations. Some folks in the chat room said, 66 blocks not meant for twisted wire. Yeah, I know that, and yet I always had really good luck with it. Yeah, Chris?
Yeah, I mean, I use them all the time, 66 and 110 in audio environments. Yeah, they're not meant for that, but they work great. But what I wanted to bring up, I don't know if you guys have ever seen these before. 3M used to make them, and now you can get them generically. They're called ST connectors, and they're crimp-on. And you can actually slide them right over the blades on a 66 or 110 block. And they're great for making quick little patch cables. Instead of, like you're talking about, double punching or trying to triple punch wires on top of each other on a block like that, you take these ST connectors and you can almost make little patch cables with them. And, just slide them right over the connector on the 66 block and then route it to wherever you want to go. I always keep those handy because they're great for, for quick, routing audio to different places in a pinch.
Left over from my contract engineering business from 10 years ago. I've still got a bunch of those ST connectors in my toolbox, and they are great. And like you said, you poke a wire in. There's a tool to crimp it, but you can use pliers and just crimp the thing down as long as it goes together well. And then, yeah, it fits right over that 66 block blade, and you can add a connection that way. I didn't typically use that for my permanent connections, but if I had to bridge something off, that would be the place to do it. Hey, we're going to bridge off for just a second here and hear a word from our sponsor, Omnia Audio. We're going to come back with some more tips on putting connectors on the end of wire, because this is consistently, it's one of the places where you find this is where trouble is, because a connector didn't get put on the end of a piece of wire correctly, or it's been used incorrectly, or the wrong wire or the wrong connector. But we'll do that in just a second. Right now, we're going to hear from our sponsor, which is my employer, and a product that I really use a lot and believe a lot. Got it at all my radio stations, and that is Omnia Audio Processors. Now, you may have heard over the years, hey, Omnia processors, those things are great for rock stations. They're good for classic rock stations. The guy that started Omnia, Frank Foti, he's a classic rocker from way back. He was the engineer for Z100, the station that took no prisoners, right? The station that went from worst to first in one book in New York City. Well, Omnia Audio has come a long, long way, and I want to introduce you, if you haven't already been introduced to it, to the Omnia One. Yeah, this is the bottom of the line, if you will, the bottom of the line Omnia FM processor. The Omnia One, I tell you, well over 5,000 broadcasters have put these on the air now. Most of them are on the air. It's available in several flavors. You can get an AM version, an FM version. You can get what we call a multicast version and a Studio Pro version. Now, the hardware is exactly the same on all these different versions. It's just different firmware that goes into it. And guess what? You can update it in the field. So if you're a contract engineer, if you're an engineer for a facility that has multiple stations, well, you can get an Omnia 1 AM or an FM, and then if you have a need for it to be in a different role later on, just update new software. It's no harder than updating the firmware in your router, for example. I think it's kind of easier than that. You download the software from our website, and you push it right into the Omnia One by its web GUI. By the way, the Omnia One, that's how you remote control it. It does have a built-in web server. So you just go right into the Omnia One with your browser. It's password protected, of course, and then you can adjust all the parameters. You can save presets, recall presets. You can set up how it's going to behave when it first starts up. For example, is it going to use the analog input, the AES input, the live wire input? You can set it to remember and properly recall the multiplex output level for FM, or the output levels for AM, or any other kind of use, or the live wire output level. Plus, it has a failover function. So let's imagine that you're feeding it with AES audio to feed your transmitter site. Well, if the AES fails, you can have it to time out and go to a second audio source, like the analog input. Or maybe live wire is your primary input on it. You can have it fail over to one of the others. There's a new feature available with it, and it's a free upgrade. If you're already one of the over 5,000 Omnia One FM users, there's a free upgrade on the Omnia website. It's for the new 5-band processing architecture. Now, the Omnia One FM has been originally sold, and over 5,000 of them out there, with 4-band architecture. Well, over the last Christmas holidays, Frank Foti and his team got to work and said, you know what? I think 5 bands wouldn't be so hard to do. So they used a little extra DSP power in the box and made a 5-band architecture. Well, we get responses from users saying, hey, this 5-band architecture, it's sweet. I'm getting prettier highs now than I did before. I thought it was good before. It's even better now. So if you want to look at the Omnia One FM processor, list price is about $3,295, $3,300. The street price in most countries ends up being under $3,000 US. You want to compare that to processors actually costing twice as much? Go ahead and do it. You're going to be very amazed and very pleased. We get great responses and great letters all the time from users of the Omnia One processor. So the AM, FM, the multicast version is for streaming purposes. In fact, the TWiRT network has the multicast version, and the Studio Pro version, which is for recording applications. Check it out on the web at omniaaudio.com/one. O-N-E. omniaaudio.com/one. And thanks very much to Omnia for sponsoring this episode of This Week in Radio Tech. All right, you know what I was just thinking? On the back of that Omnia 1 processor, we've got the whole gamut of connectors. There are XLR connectors for the analog input. There's actually an RJ45 modular connector for the AES input, and the folks at Omnia do provide a little adapter cable if you just insist on having an XLR for AES input, which is the norm actually. Then we provide the cable right in the box. There's also an RJ45 connector for the Ethernet, for the live wire or remote control over Ethernet. And there's BNC connectors. We're going to get to those in a few minutes for the FM functions. There you go. There's the back of it. And look, there's even some of those dreaded DB9 connectors, the ones that Chris Tarr was telling us how to wire up. So there's also a power connector on the far right. So you see all the variety of connectors on the back there. Let's see. We haven't talked. We touched on the RJ modular connectors. Let's talk about those just a bit more. Tom, you were alluding that putting these connectors on requires stripping the cat cable and then untwisting the wires. And you know what? If you untwist them, they've still got curliness to them, right? Like wavy hair. So I wouldn't know anything about. So what I do, I have this technique for straightening these wires out so they're no longer curly and wavy. I pull them all as tight as I can out. And by the way, you know, you only need a ½ inch or so of these exposed. But it's impossible to deal with a ½ inch of wire sticking out there. So I strip a couple inches of wire. I strip the jacket. I strip a couple inches of jacket off of a Cat 5 cable or a Cat 6 cable. And then I'll untwist these 4 pairs. And then I will flatten them out with I'll grab the cable with one hand, and I'll flatten out the wires with the other hand. And if you just kind of shimmy them like this while you pull on them, that tends to loosen the curliness of those wires. And so then I'll kind of pull my finger across the wire flat, like I'm trying to flatten them out. And after 2 or 3 times of doing this, I mean, just 10 seconds worth, hey, they're all flat. Then I got to try to put them in order, right? So you got to be careful about making sure you got the right order of wire there. You can find all that online, what color order that the wires are supposed to be in. And get them all, and then, flatten them all out, double check them, triple check them, make sure they're in the right order. And then, now I know how far to cut it off now just by looking at it, but, hold it up to your RJ connector, get your diagonal cutter, your dikes, and cut off all that excess wire. And now you've got, a ½ inch or just a little, maybe 5/8 of an inch of wires that are flattened out. Once again, flatten them out again. Double check the colors again, because if you got 2 of them crossed, you're just out of luck there. You got to cut the wire off and do it all over again. And then take the whole thing and shove it in the connector. Now, I usually go ahead and take that RJ modular connector, and I go ahead and pre-insert that into my crimp tool. That way, I'm already holding it. So I'll have the connector in the crimp tool, not squeezed down yet, and then I'll take the wires and slip them into the connector, which is in my crimp tool, and as soon as they're in, crimp down on the crimp tool, and ta-da, there it is.
I can tell you, I do so many of those: orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. I do the color code in my head. But one thing you really want to invest in if you're going to make any of these cables, any more than a couple, is a good cable tester. I have a really nice one that also functions as a TDR, so that you can figure out if there is a problem, which end of the cable is a problem. But it'll tell you if you have cross pairs, if you have something wired incorrectly, because nothing slows you down faster than a connector that has a broken wire inside one of the connectors or something like that. And it can tie you up for literally half an hour trying to trace down which end of the cable's bad, where the problem is in the cable, and what's wrong with it too. So, invest in a good cable tester because it'll just save you a whole lot of time down the road.
And make sure you have the proper connector for the type of wire you're using. Check the wire gauge with the manufacturer, because if you're using a connector that's intending to be, that's intended for like a 24 gauge wire, and the cable you have is actually 26 gauge, it may not contact properly, and you may have problems after the fact, even though everything looks like it's fine.
That's a good point. And I never have actually checked for that. I've just always assumed that, hey, if I buy the roll of cable at this store, and I buy the pack of connectors in the same store, it's going to work together.
Well,
that's not always. I've been lucky. It's always been the right size, apparently.
Well, that 6-pin RJ11 I showed you before, that I'm showing you now, was bought from a popular store. I tend to use it, the ASU ham rigs, the 2-meter rigs, use these for the microphone connector and push to talk when you're interfacing them to something else. That store also sells phone cable, which makes it really handy. You know, this is basically a telephone connector. Let's hook it up. It's the wrong gauge. If I use that cable and this connector to make a cable that I'm using for some project, I usually have to shim the thing to make it contact properly, because the pins, when I crimp it, that makes contact with the wire, but the pins go in too far and it won't contact in the radio. So I found that using what I call regular telephone cable, actually Western Electric cable that the phone company uses, they work every time.
Huh.
So it's like I can buy the connector, I buy the cable that's supposed to go with it, doesn't work.
Well, and again, that's where you want to get the high quality stuff too, because the RJ connectors that you use too. I've used some. In fact, I have a box full of them sitting in the basement here of some real cheap connectors, and I'll tell you, it takes me 2 or 3 tries to get those the wiring in there correctly, because there's so much of a gap from where the wires go in to where the slots are that the wires seat into for crimping, that they never make it into the right slot, and they end up getting crossed and things like that. So invest in good quality connectors too, because it's just like a soldering iron. I hear a lot of people go, oh, I can never do those connectors right, I always mess them up. But if you have the right stuff, it is so easy to do. It's dead simple. Get yourself a good crimp tool, buy the high quality connectors, buy some decent cable, buy a cable tester, and I guarantee you can make 100 of these cables, and 100 of them will work every time.
I want to show you the beauty of the RJ modular connector is just amazing how well this thing is engineered. I'm sorry if it's out of focus there. If you look at this thing from different angles, it's just gorgeous, and even the crimp that crimps onto the jacket. And by the way, you want to. Oh, the last thing I do before I push the crimper down, if the jacket isn't quite in there, I just go ahead and push the jacket on in there, shove that jacket home, so that when you crimp it down, the strain relief here, this grabs onto the jacket, holds that in. I can't tell you how many connectors I've had problems with where people didn't shove the jacket in there as well. It means they had the wires too long. But anyway, you can shove that home. Now, here's what you got to remember, and I absolutely love the detangler, the thing that keeps it from tangling up. But you got to put that on first. If you don't put that on first, then unless you're dealing with a very short cable and you haven't put the other end on, you're out of luck. But when you put all that together, hey, it works a whole lot easier for the for actually wiring it and dealing with it. And now I'm all tangled up with my headset. Great. Hey, so we've only got a few minutes left, and I want to talk about the other couple of audio connectors. We'll have to do RF on a different show. Let's mention what are a couple of audio connectors that you hate or that you love to deal with or have finally gotten good at. XLRs are real popular. So
XLRs are really easy.
Tom, tell us about XLRs. How do you do those right? What do you have to watch out for?
Well, for one thing you need to do is make sure you take that connector and you have to, put it in a pan device or some other type of device to hold it. In a pinch, a pair of pliers with some electrical tape around the handles will do. The one thing to watch out for, if you're doing a whole bunch male and then female, just keep track of what you have, because pins 1 and 3.
That's the problem.
Flip.
1 and 3. Yeah,
and if you're not paying attention, you'll make a whole bunch of female connectors backwards with the ground in the wrong place.
Yeah.
You know what I do? I actually I have a business card in my wallet where I have the male and the female and have the pins labeled with a diagram. And I always just, even though I can usually do it by memory, I whip out the card every time I do those connectors, just as a reference to remind myself to do it correctly for male versus female. That way I never forget.
Is pin 2 hot?
Pin 2 is, I think the convention nowadays is pin 2 is hot. It used to be kind of a wild card, but pin 2 is, I use pin 2 is hot, pin 3 is minus, pin 1 is always ground, no matter what the standard.
Well, that agrees with the graphic just shown there. Pin 2 is always hot, and if you got to, and that, to me, that's easy to remember, because the ground, and I don't know if that graphic is still available, the ground and the potentially also grounded pin 3, in case you have to make an unbalanced connection. There you go. 1 and 3 are next to each other, and so 1 is always the shield or ground, and then 3 would be the next closest thing to ground. Okay, in a balance situation, I realize it's neither here nor there. It's equal but opposite to the pin 2. But you keep the phase right, and when you do all your wiring, then you don't ever have a stereo problem, or you can even avoid an absolute phase problem.
Well, that's an important point, Kirk. When you're wiring an XLR connector or any connector actually for balanced audio, you need to keep the phasing in mind, because what will happen is at some point, someplace in the system, an AM radio station, an FM radio station, at some point you're going to combine that to mono. And if you have plus and minus, and they get combined to mono, it'll sound just fine. If you have one of those channels upside down, you're going to get what's called phase cancellation in the mono channel, and your announcer won't exist anymore, because that's microphones are usually mono. Or you'll play a Four Tops song and won't have any vocals, but you'll have all the instrumentals.
Another good tip too with wiring XLRs, because remember this with RCAs. Always remember to slide the outer connector of the actual connector part, I don't know what you call it, over the wire first before you solder the rest of the connector on, so that you can put it all back together. Because I know you guys have been through this too, where you get it all soldered up and you look over and there's the rest of the parts sitting on the bench, and you have to desolder all the entire connector, slide the cover back on, and then solder it all back together again. So I've done that more than once.
Yeah. I know. So, and you know what? I still do it to this day. No matter how many I've made, I still do it at some point.
So what's your advice about two quick things here? First, advice about how do you keep from burning your fingers? Is a pan of ice or some other kind of ice the only way to do that?
Well, the pan of ice or some other devices is you really need that to hold the connector steady, so you're not wiggling the connection when it's drying, so you don't end up with a cold solder joint.
Mm-hmm.
I use a pan of ice and locking forceps, which are great for that. They kind of have the curved tip on them, and then they ratchet together, and you can hold the wire with that and keep it nice and tight, and then solder it into the pan of ice. That's if you're having to work with high temperatures. Otherwise, any good engineer at this point has calluses on their fingers that you don't even feel it anymore.
So do you tie the drain wire of the cable? Do you tie that to the little loop that will, when you put the barrel together, that will tie it to the whole body of the connector? So is the body grounded, or is just pin 1 grounded?
I typically do pin 1 unless it's a microphone. Then oftentimes I'll ground the entire thing, but generally I don't do that.
So with my cable, I've used my cable where by the time you pull the shield wires back, you've got a bundle of wire there. And so I have taken that and pulled it into a fork and then tinned both of those, and one of them goes to pin 1 and the other one goes to that loop that connects it to the body. This is for mic connectors, because the mic cable has plenty of wire to let you do that. Is that reasonable?
Yeah.
Tom?
I'm sorry, Kirk, say that again, please.
Oh, I was wondering about this notion of on the XLR connector. There's actually 4 connections. There's pin 1 for ground. There's 2 and 3 for plus and minus, and then you've got this body connector that's available. This little loop that when you assemble the whole thing and turn the screw, this allows the body of the connector to be tied to ground or shield of some kind. Do you ever tie that to anything?
Actually, I don't, and it depends on the manufacturer of the connector. There are some manufacturers that have that extra connection, and some that don't. I've been in a couple of situations using the ones where you do have that extra connection, and I've had to ground it to ground the case on the microphone. For whatever reason, the case on the microphone was picking up interference from someplace. Whether it was a fluorescent light ballast or something, and I've ended up having to make that connection and tie it to pin 1. So generally, I don't use it.
We've got a lot of things still to talk about in terms of wiring and grounding. In the chat room, people have asked, "Hey, well, shouldn't you just connect the shield at one end of a connection?" how do you deal with that notion that the shield should only be connected at one end, or should you carry ground all the way through? We haven't even gotten to RF connectors yet, or the BNCs that we thought we'd be able to get to, but we are out of time. Chris Tarr, thank you for being with us. Have you got any last-minute advice for us on the subject of putting audio connectors on cable properly?
Just like I said before, high-quality parts and connectors, and take your time.
Mr. Ray?
The paperclip is underrated. Just make sure you have chewing gum when you use it.
I've used a paperclip to make a bridge. If I need a high-quality, strong loop, just cut a little piece of paperclip off and bend it with needle nose, and there you go. And
works like a champ.
Yeah.
So, all right. Hey, guys, we got to go. Chris Tarr from Muckwonago, Wisconsin, thank you for being with us. Appreciate it very much.
Thanks for having me.
All right. Good to be had. And Tom Ray, thank you for being with us from the Hudson Valley of New York. Appreciate it.
You're welcome. It's always a pleasure, Kirk, and always a lot of fun.
Hope to see both of you guys back next week. I'm Kirk Harnack, and thanks very much to Omnia Audio for sponsoring our show. Check out the Omnia One audio processor. All the versions are mentioned right there, including new software you can download for free to upload to your Omnia One FM and turn it into a 5-band processor. Plus, there's presets galore on the Omnia website. Check it all out, omniaaudio.com/one. That's it for us on This Week in Radio Tech. We're going to be back with you next week. And I'm looking forward to joining the rest of the TWiRT crew at the TWiRT Brick House this coming weekend for a little get-together and party we have there. Hope to see some of you there, too, some of our friends of the show. Hey, thanks for your comments, and always look for the posts of the show at twit.tv/TWiRT. That's where the new shows are. And, of course, you can always check us out at the old website. We do keep that up to date with the shows as they're published at thisweekinradiotech.com. You guys take care. Have a great week. Thanks for the help from the chat room. We appreciate your comments very much. Bye-bye, everybody.